Our process starts with ingot aluminum, which we purchase from any one of the large aluminum companies. This ingot, along with scrap from various parts of the operation, is first melted in this furnace. A unique aspect of our process is the fact that cans after use can be salvaged and also remelted for subsequent fabrication into cans again. Molten aluminum pours from the discharge of the furnace into the casting machine. The molten aluminum is solidified between the surface of the wheel and a metal band and emerges from the underside of the wheel as a continuous aluminum strip. We are casting here at the rate of approximately 3,000 pounds of aluminum per hour. This strip, which is approximately 900 degrees Fahrenheit in temperature, must now be reduced in thickness down to gauge. The first step is this hot rolling operation. The strip enters the mill 3/4 of an inch in thickness and emerges 3/16 in thickness. This white milky stuff you see splashing around is lubricating oil. It is necessary to prevent sticking of the aluminum to the mill surfaces and to keep the rolls themselves cool. The second rolling operation is the gauging operation. In this case, the strip is rolled to 1/8 of an inch in thickness and is coiled in 700-pound coils, as is being done here, or is blanked into aluminum slugs or discs for the subsequent can forming operation. This is a finished lid strip coil. The gauge is checked and the strip is carried over to the blanking press. Before blanking, it must be immersed in a thin lubricating oil. Pure aluminum, as we use here, is extremely sticky, and any tool or punch must be thoroughly lubricated to prevent sticking of the aluminum to the tool. this continuous casting operation is unique in the world today. The blanking press floats on the line. As the slack loop in the aluminum strip builds up, it triggers the starting switch of the press. And as the press chews up the strip, it pulls the slack loop down to trigger another switch and thus shut itself off. Scrap emerging from the press is normally chopped up into small pieces by the guillotine cutter and returned to the furnace. The slugs are conveyed to an annealing furnace where they undergo 1 hour at 900 degrees Fahrenheit to soften them for the subsequent extrusion process. This is an overall view of our annealing furnace. The drop test, here shown in slow motion, is a good way to determine whether a slug has or has not been annealed. You will note the higher degree of elasticity on the unannealed slug on the left. After annealing, the slugs must now be tumbled and deburred. After tumbling and deburring, they are immersed in a lubricating solution and dumped into another trommel where they are dried. On completion of this process, they are ready for extrusion. The coils of lid strip also must be annealed before rolling down to lid gauge. The strip in these coils is of course 1/8 of an inch in thickness and must be rolled down to 14 thousandths in thickness before being stamped into lids.